Hello, space enthusiasts. Today we are going to take you on a journey deep into our solar system. Yes, the solar system is just one of billions of star systems in the universe, but it means a lot to us. Now we'll explore everything from the star at the center of this system to the countless celestial bodies orbiting around it. Our star, the Sun, is the main source of life on Earth. Plants use the sun's energy for photosynthesis to produce food, and this is how we take our place in the food chain. The Sun is the closest star to us, only 8 light minutes from Earth. The next closest star, Alpha Centauri, is about 4.3 light-years away. The question of where we are in the universe has been a great question waiting to be answered since ancient times. Until Copernicus, the answers to this question were mostly philosophical and not based on observation. However, with the birth of astronomy, scientific answers to this question began to be sought. When Galileo turned his telescope to the sky, his discoveries led to many new insights about our solar system. The nebular theory, with the new perspectives brought by science and technology, is now considered the best explanation of the formation of the solar system and the distribution of the objects we find in the solar system. A nebula full of dust and gas, most likely the remnants of a supernova explosion, pulled the materials inside closer to the center of the nebula under the influence of gravity. The material that accumulated in the center formed a structure called a protostar, which would later form the Sun. Over time, the material orbiting the protostar moved closer to the center of the protostar, and the rotation speed of the nebula increased due to the conservation of angular momentum. Eventually, the rapidly rotating nebula formed a disc-shaped structure which eventually flattened to form the planets. The formation of planets is divided into two categories: rocky planets and gas giants. Rocky planets are formed by the accretionary growth of microscopic galactic dust. These microscopic particles coalesce under the influence of electromagnetic forces and form larger fragments. As the particles grow larger, the gravitational force increases and the accretion process accelerates. When they reach a sufficient size, these objects are called planetesimals. As a result of various external influences, planetesimals undergo orbital changes and collisions, and eventually, sufficiently large bodies that settle into a stable orbit form rocky planets. Gas giants form through a similar process of accretionary growth. The main difference, however, is that rocky planets form on the frost line close to the Sun, while gas giants form on the frost line far from the Sun. As a result, gas giants are formed by the accretion of massive chunks of ice. Thanks to their high gravitational pull, these planetesimals attract free gas from the nebula, creating a thick atmosphere around them. Satellites orbiting planets are formed in basically 3 different ways. First, the moons of gas giants are formed when the gravitational pull of the planets pulls gas and dust into their orbits as they form. This material gathers around planets such as Jupiter, Saturn, and Uranus and forms disks around the planets, just like the nebula in the formation of the solar system. These disks eventually turn into moons. Another satellite formation idea is that planetoids orbit some planets to form moons. Phobos and Deimos, the moons of Mars, are a good example. These planetoids orbited Mars under its gravitational pull and became its satellites. The formation of the Moon, Earth's satellite, is a little different. According to the generally accepted theory, the Moon was formed when the Earth collided with a planet called Theia. During this collision, a large amount of material was hurled into space, and over time these materials combined to form the Moon. Rings in the solar system are formed by countless particles orbiting around the planets. There are 4 ring systems in our system: Jupiter, Saturn, Uranus, and Neptune. There are 2 different theories about the formation of rings. According to one theory, rings are formed when an existing asteroid or comet hits an old satellite orbiting the planets and breaks up. These fragments orbit in an irregular pattern, and tidal forces caused by gravity prevent them from coming together, preventing the ring from breaking up. The other theory is that small particles do not create a favorable environment for the formation of a large satellite due to tidal forces. Since these particles cannot come together to form a large satellite due to tidal forces, they remain in the form of ring systems. Which theory applies to which planet is still a matter of scientific debate. The asteroid belt is a region of rocks between the orbits of Mars and Jupiter that are not large enough to form planets. Jupiter's gravitational pull prevents the accretionary growth phase that these rocks go through in planet formation. On the other hand, the Kuiper belt and the Oort cloud also contain many small rock fragments due to the gravitational pull of gas giants. Some of these rarely visit the inner solar system and are called comets. These icy planetesimals alter the orbits of the gas giants, and some of them bring their icy water to Earth. Thank you for being with us today. I hope you've learned something new with this information that helps us better understand the formation of our solar system and our place in the universe. If you want to see more science and space-related content, don't forget to subscribe to our channel and turn on notifications. If you liked our video, please share it and let us know what you think in the comments. See you in the next video. Bye.